Okay guys, now we're going to do a quick video on skill 4, which is solving word problems that involve proportions. And in your packet we gave you an example problem, and I want to walk you through that, and then we'll do one more together as well. This example says an adult rhinoceros beetle weighs only 0.525 ounces, but can carry about 446.25 ounces on its back. If a person were as strong as the rhino beetle, how much weight could a 100-pound person carry? When I set up a proportion, remember a proportion just means two ratios that are set equal, okay? So two ratios that are set equal. There should be something in common about everything in the numerator. There should be something in common about the two things in the denominator. There should be something in common about the two things in this fraction, and something in common about the two things in this fraction. Now, sometimes we can use the units that they give us to help us. So for instance, notice it says an adult rhinoceros weighs only this many ounces, but can carry this many ounces. That's a good commonality. So I'm going to put right here 0.525 ounces. And down here, I'm going to put 446.25 ounces. Okay. Next it says, if a person were as strong as a rhino beetle, how much weight could an 100-pound person carry? So here's pound. So over here I have my ounces. Over here I'm going to put my pounds. Now the real question becomes, do I put the 100 pounds on the top, or do I put it on the bottom? Notice it says an adult rhinoceros beetle weighs this much. This is how much the rhinoceros weighs. This is how much the rhinoceros can carry. So for the person, in other words, this here was the person. This was the rhino beetle. Okay. The person weighed 100 pounds. So person and weighs, that should go in the top. We're trying to solve for how much the person can carry. So when I set up my proportion, I should have things in common in each of the rows, if you think about it. So up top, it's all about how much things weigh. The bottom is about how much things can carry. This whole thing was about the rhino beetle. This whole thing was about the person. And when I did it over here, you'll notice that I wrote it all out instead as a list. So I said the rhino beetle weighs, the rhino beetle carries. The human weighs, the human carries. So you can kind of see how they match up. And so this was another way to write it right there. Okay. So you can look at that later. Well, now if we're going to solve this, we said if we have a proportion, we have to cross multiply. So I have to do it like this and like this. So I'm going to have 0.525x equals 100 times 446.25. Okay. And I get x by itself, so I have to divide by this. So over here I'm going to have 100 times this divided by this. And this is where we're just going to use our calculator to type in. And now you want to be careful. You type all this in correctly. So I'm going to have 100 times 446.25 divided by 0.525. Okay. Wow, that means that if a person was as strong as a rhino beetle, they could carry, holy cow, 85,000. Now I have to think about what my units is. So notice this was ounce over ounce, so there should be pounds over pounds. So a human, if they were as strong as a rhino beetle, could carry that many pounds. That is crazy. So that was our example. Let's flip to the back of the worksheet. We're going to do one of these back here together. Why don't we actually just do number 1? Okay. Number 1 says the scale on a map is 0.25 inches for every 20 miles. Okay. So this is a scale. So this is the scale or the map, and it represents an actual 20 miles. The distance from Montgomery, Alabama to Atlanta, Georgia is 2 inches, and they're talking about on the map. So 2 inches on the map. How far is Montgomery from Atlanta in real life? So we want to figure out how far it is in real life. So notice some commonalities. We have what's going on the map, what's going on in real life. Okay? So let's do this one. We're doing number 1. Remember, we're going to set up a proportion. Okay. Let's start by figuring out what's going on the map. For every 0.25 inches on the map, it's 20 miles in real life. So now we want to think about the distance from Alabama to Georgia. Okay. On the map, it was 2 inches. And I'm actually going to change this really fast. I'll explain in a second. We want to figure out how much it is in actual miles from Alabama to Georgia. So this is actually what's happening. I should really put it here on the map. This is what's happening, the real distance. Okay. When we compare what's going on a map to what's going on in real life, we actually call this the scale. Okay. But some things that are going to help you is, you notice inches are together on top, right? So that means we're going to have miles together here on the bottom. Okay. Everything underneath this was Alabama and Georgia, and then everything in here was telling me about the information in the map. So if I have a proportion, I'm going to cross multiply. So I'm going to have this times this equals this times this. Well, it's easy for me to figure out. I know that 2 times 20 is 40, so I'm just going to simplify that now. And now I'm going to divide both sides by 0.25. This is when we can use our calculator. I'm going to say 40 divided by 0.25, and that gives me a value of 160. So we want to make sure we put units in our answer. We're saying what the real distance is from Alabama to Georgia. The real distance is 160 miles. So remember, on this packet, you're supposed to be showing the work for each problem on loose leaf paper. Make sure you staple it on when you're done. You only have to pick 10 of the 17 problems, but make sure you label them so we know which ones you did.